Hey, ninth graders. All right, this is Mrs. Johnson. We are on page, let's see, in your math binder, this is page 32 that I'm starting on, and it's called Solving Equations with Variables on Both Sides. So what you're gonna notice is this is actually 2-page notes, but the second page, I don't know why I numbered these really poorly. You'll notice it went from page 32 to page 34. That's a typo. Don't fix it. I'm just gonna roll with the typo. Yes, it does mess up the rest of your notes for the whole year as far as the page numbers go, but like it wouldn't be a typical year in math without me messing up the page numbers. So you're welcome for keeping things normal for you. Okay, let's look at this first part together. It says, the following is a model of the equation 5x plus 2 equals 3x plus 12. Your job is to use the model to solve for x. Show the algebraic steps below. So looking at this model, we've got 5 x's over here and 2 1's. And to kind of clarify this, I'm going to throw the letter x inside these because these are all representing some unknown quantity x. And then over here, there are 3 unknown quantities x. And then all of these blocks are just a single 1 unit. That dash sign in the middle is going to be our equal sign in this image. So I'm going to start by canceling whatever I can on both sides. So if there is a single 1 over here, I can take away 1 from the left, but to keep this equal, I also have to take away 1 from the right. Then I can take away another 1 from the left, and I can take another 1 from the right, because I'm keeping everything equal by eliminating on both sides. Okay, then I can start eliminating x's. So if I eliminate an entire x, I have to eliminate another x. And I can keep going with that method. And I've got 2 x's left. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1's. All right, so now my job is to try to match these up. How many 1's match up with each of those x's? It has to be equal because x doesn't change the amount that it is. So right here, I'm going to start by splitting this 10 in half. So I just circled 5 boxes, or 5 little 1's. The first x can match up with those 5. The second x, I'm going to have it match up with the other 5. So every x matches up to 5. So I got x equals 5. Now over here on this side, I'm going to show the work algebraically, how we do in a regular math problem. So if I had 5x plus 2 equals 3x plus 12, the first thing that I always do on these sorts of problems, and we talked about this in the 8th grade, is I try to get all the x's on the same side after I've distributed and combined like terms, which this doesn't have any distribution. I don't have to combine like terms on the left or the right. Sometimes you'll see me draw a little line in the center there. That's just like this. It's to keep the 2 sides separate. You don't have to draw that line. I'm just doing that to make sure that we keep everything lined up nicely. I want to see all of your work every step of the way. So I'm going to begin by getting rid of this 3x. Now that's a positive 3x. To get rid of a positive 3x, I have to subtract 3x. So I'm going to subtract 3x. Remember how I subtracted 3x's by crossing them off? Okay, over here, I also crossed off 3x's. So I'm going to also subtract 3x on the left. Now on this side, 3x minus 3x, that's 0. It's eliminated. On this side, I have 2 x's left. But I also still have the positive 2, so I'm going to put a plus 2, equals 12. Okay, now I want to eliminate those 2 boxes. So to get rid of a positive 2, I'm going to subtract 2 from both sides. So I'm left with 2 x's, and then 12 minus 2 is 10. Now, I'm not doing math right now. I'm just doing math. Excuse me, I did that backwards. I'm not doing magic, and sometimes people think that I'm just coming up with random crap, or I'm doing it in a different weird order. I'm following the natural order that would have happened from this image. So I did 2 minus 2 because that would give us 0. The last thing that I would have to do to undo the multiplication of 2 times x is I would have to divide by 2. 10 divided by 2 gives us x equals 5. So that was your quick reminder on solving equations. But if you're still feeling like you are struggling solving equations, I want you all to write down these steps in the margin. The first thing I want you to do every time you see one of these problems, if possible, is distribute. Please write that down. So I'm writing in the question/notes, and I'm going to write distribute. That's your first step. Now, I know sometimes you do not write these things on the side. You have to, people. I've been looking at some of your notes, and I want to see completely filled in. Okay, after you distribute, second step that I'm going to write is combine like terms on each, and I'm putting the word each in caps, on each side of the equals. That's just equals in parentheses. All right, step 3, move all variables, that's like your letter, all X or Y or whatever it is, all variables to one side of equals. So you're going to get all the variables to the same side. Step 4, you're going to use additive inverse. So either the addition property of equality or the subtraction property of equality, whichever one. And then step 5, you are going to multiply or divide. And I'm kind of thinking instead of additive inverse, to make that make more sense for more people, I'm just going to say instead of use additive inverse, I'm going to say add or subtract. Because that's what you're solving there. All right. And then one thing that I want to make very clear at the bottom here, if the problem starts with a fraction, leave answer in fraction form. A lot of times people ask, should I make it a decimal or should I leave it a fraction? If there's a fraction in the question, your answer should also have a fraction. If there's a fraction and a decimal in the question, then sometimes it's either one. But like looking at problem number 5, for example, there are just fractions and whole numbers. And compared to number 4, there's decimals all throughout. And I would expect a decimal answer here, but a fraction answer there. All right, let's look at problem number 1. Again, you are going to see me when I do these problems. I will almost always draw this separation here so that I can help you keep your notes nice and orderly. So the first thing that I'm going to do is see if I can distribute. Well, on the left side, nothing to distribute. There's no parentheses. And on the right side, no parentheses as well, so I don't have to distribute. Now, combine like terms on each side. Nothing goes with that 4x. Can't combine anything with it. On the right side, nothing goes with 2x. Now, some of you might be thinking, yeah, but 4x and 2x could be combined. They can't. They're not on the same side. So then we move to the next one where we can do that. Move all variables to one side. Now, this is going to be different than adding 4x and 2x. We don't just add those things together. They're on opposite sides of the equal sign. So we want to get the x's to the same side. So would it be better to move 4x from this side over to the right? Or would it be better to move the 2x and get rid of it on the right side, move it to the left? Think about what that would do. So if I were to subtract 4x, these would be gone. And then subtracting 4x here, I'd get a negative, and then that would be a 0. Then I'd have everything on the right. I don't love that. I almost always will move the smaller one. Almost always I move the smaller one. So the smaller one is 2x. So how do I get rid of a positive 2x? Well, I want to subtract it because it's positive. So underneath that 2x, I'm going to write minus 2x because 2x minus 2x is 0. Then I have to do the same thing on the left side, minus 2x. Okay, these eliminated. So now I have 4x minus 2x's gives me 2x. On the right side, what's left? Well, there's just a 12. So 2x equals 12. All right, next, add or subtract. Is there anything that I can do to add or subtract here? Well, there's nothing being added or subtracted, so I don't have to undo either of those things. Last, multiply or divide. Okay, there is multiplication here, 2 times x. So to undo multiplication, the multiplicative inverse would be dividing by 2 on both sides. So I'm going to divide by 2 here because that will give me 1x. And on the right side, I'm going to divide by 2. 12 divided by 2 is 6. All right. Now, if you had wanted to, and I know some of your teachers have made you do this in years past, or some of you have done tough tests like end of year testing, and you want to check if your answers are correct. The way that you can do that is, and I want you to show it over here right now, but I'm not going to make you show this on every problem, just this first one. In order to check, you take that original equation, 4x equals 2x plus 12. Everywhere that there's an x, I'm going to put 6 in its place. So instead of 4x, that's going to be 4 times 6 equals 2, but instead of x, I'm checking my answer, times 6 plus 12. Okay, 6 times 4 is 24. 2 times 6 is 12, and that plus 12 I haven't touched yet. 12 plus 12 is 24, so I get 24 equals 24. If this is true, which it is, then your answer is correct. If it was not true, then your answer would be incorrect because it doesn't satisfy that equation. All right, so that's how you can check your answer. Again, I'm not going to make you do that on every problem, but on a test, it might be a good idea because then you can verify that you did the problem correctly. Okay, problem number 2. Nothing to distribute, but I can combine like terms because if you look here, that 4x and the 2x are on the same side. Here's a very common mistake. I always get somebody who does this. That's really bad. It looks so good, but it's not good. Okay, so why is that not a good idea? Why can't you do this? Well, remember, last time we subtracted 2x because they were on opposite sides of the equal sign. These are not on opposite sides of the equal sign. You can't subtract 2x here. That's a bad thing. It's like saying this is equal. Let me subtract a bunch from this side, and I didn't do anything to the other side. That's not okay. All right, so don't do that. Oh, it like tears a little part of my soul out and stomps on it every time I see that. Okay, so these are on the same side. Underline them. Let's combine them. What is 4x plus 2x? Well, 4 plus 2, I can add those coefficients, and I get 6x equals 12. All right, nothing that I can add or subtract. So I need to undo this multiplication. I'm going to divide by 6 on both sides. When I do that, 6x equals 12, but dividing by 6 over here, I get 1x. And on the other side, 12 divided by 6 is 2. All right, let's look at, actually, I want you to go ahead and try problem number 3. Try problem number 3, so push pause, because if you don't push pause, you're gonna see the answer in a second, which is like really, I don't know, dishonest, but I'm gonna go over the answer in like 1 second. Do it first. Okay, so I think that I did this method a little bit different than some of you, which is why I did it that way. I'm guessing that some of you subtracted 3x from both sides. That's totally fine. If you subtracted 3x's, you would have had a negative 7x over here. Then you would have to subtract the 6 and you'd have a negative 42. And when you divided by negative 7, you would still get positive 6 because a negative 42 divided by a negative 7 would be positive 6. I chose to add 4x. Can you see why I might have chosen to do that? It's not because I wanted to trick you. It's actually because I think adding 4x was nicer in this problem, because then I have positive numbers over here, and then I can add 36 and I have positive numbers over here. So I added 4x to both sides. I added 36 to both sides to get rid of that minus 36 because the opposite of subtraction is addition. And then I divided by 7 to get x equals 6. All right, let's look at problem number 4. It's a decimal. Okay, we already panicked now. Let's actually do the problem. Separate the two sides. Nothing to distribute. I can't combine over there, can't combine over there. So let's get all the x's to the same side. This negative 0.2x, I'm gonna get rid of that because I like adding instead of subtracting. So I can add 0.2x. I have to do the same thing over here, plus 0.2x. These are gone. 0.7 plus 0.2 gives me 0.9x minus 0.6 equals negative 0.42. All right, I don't think I can do this next part in my head. I need to get rid of this subtracting 0.6. So the opposite of that would be adding 0.6 on both sides. Okay, so negative negative 0.42. I just got rid of the 0. Plus 0.6 gives me 0.18. So I have 0.9x equals 0.18. Last step, divide both sides by 0.9 because I'm undoing the multiplication there. So 0.18 divided by 0.9, and I get 0.2. Do you have to put the 0 in front? I don't know. I mean, it's like your life, so you can choose whether or not you want to. Typically when I'm writing my final answer, it's a little bit more proper, so I will write it that way on the final answer. But if I'm just like sketching down math, I don't confuse myself by not putting the 0 there. So there's my 2 cents. All right, I want you to try this one. I know, it's a fraction. Push pause, see if you can get some of it done on your own. Push pause, try it. Those of you who are waiting for me to do the answer, shame on you. All right, I'm gonna go through this one. Separate the 2 sides. I need to get rid of one of these 2 things. 1/3 is smaller, so I'm gonna subtract that off. Subtract 1/3 x. Subtract 1/3 x. You might have been tempted to change it to a decimal. That's a bad idea because these are repeating decimals. It wouldn't be very nice. Okay, 1/3 x minus 1/3 x is 0. So I have negative 8 equals 12. And then 4/3 minus 1/3. If I do that, 4/3 minus 1/3, I get 1. Oh, you can't see that. 4/3 minus 1/3, yeah, that makes total sense because if I have 4/3, take away 1/3, and now I have 3/3. 3/3 just 1. Okay, so that is 12 plus 1x. I did not have to write the 1 in front of the x. I did that almost exclusively to make sure that you knew that that is so redundant and weird. Okay, let's get rid of this 12 now. The reason I'm getting rid of the 12 and not the 8 is because the 12 is on the same side as the x. Moving the 8 would do nothing to get closer to being alone. So subtract 12, subtract 12. Negative 8 minus 12 is negative 20 equals, I'm not writing 1x, I'm just gonna say x. Okay. On problem number 6, decide if you want to continue on with fractions or decimals. I'm willing to bet that most of you probably would rather do this as decimals. So eventually I'm going to switch this to a decimal, but I'm going to start by getting rid of this negative 1/2 x. The reason I didn't choose the negative 0.25, negative 1/2 is negative 0.5. If I add that to both sides, this side's going to become positive because this is a bigger fraction. 1/2 is bigger than this one, which is technically 1/4. Okay, so I'm going to add 1/2 x. And if you don't know which side to move it to, I don't know, just choose a side. Move it to the left if you'd like. Okay, over here, these are gone. And if I have the 3 that I never touched, negative 0.25x plus 1/2 x, if I do that math, and yes, you can type that right into your Desmos calculator, you would get either 1/4 or 0.25. I'm gonna write 0.25x equals 9. Okay, sometimes people wanna get rid of this 0.25. That's not the thing that we're trying to get rid of because that's got the x. We have to get rid of the 3. So subtract 3. And I have 0.25x equals 6. I can divide both sides by 0.25. And I get x equals, and 6 divided by 0.25 would give me 24. All right, how do I do a problem where there is distribution? Let's look at this. Separate the two sides. And remember, the first step is always distribute. So I'm going to distribute over here. 7 times x, 7 times 2. And I have 7x plus 14. And then remember that minus 4x, I don't distribute to that because it's not inside the parentheses. So I'm just going to write minus 4x. On the other side, I need to distribute 2 to x, 2 to 5. When I do that, I get 2x plus 10. Okay, there's a lot that can be combined. On the left side, 7x and negative 4x, those are like terms. Let's combine those. 7x, take away 4 of them, gives me 3x plus 14 equals, and on the other side, nothing changed, 2x plus 10. Would you rather subtract 3x from both sides or subtract 2x from both sides? I would rather subtract the 2x because it's smaller. So subtract 2x, subtract 2x. 3x minus 2x gives me just 1x or x plus 14 equals 10. Last step, minus 14, and I get x equals negative 4. All right, push pause, try the last one. I'll go over it in like a second. Okay, again, you're gonna see me separate the two sides. No, you don't have to do that. Please don't complain about the fact that I am though, because the reason I do that is to keep this nice and orderly so that my screen doesn't get all like blurry and all over the place. And I suggest you do the same, but again, it's your life. You can choose how to show your work. Okay, I have 10x, that didn't change. 2 times x is 2x. 2 times negative 5 is negative 10. On the other side, 18x plus 26. Now on the left, I need to combine like terms. 10x plus 2x is 12x minus 10 equals 18x plus 26. Would I rather get rid of 12x or 18x? I'm going to go with the 12x because it is smaller. Minus 12x, minus 12x. Over here, these are gone. I have negative 10 equals 18 minus 12. 13, 14, 15, 16, 17, 18, 6. 6x plus 26. All right, I need to get rid of the 26 because it's on the same side as x, but it's being added. So I subtract 26 from both sides. On the left side, I have negative 36. On the right side, just a 6x is left over. Divide both sides by 6. And negative 6 equals x. All right. Now we are going to transition to the back page of this because I want to show you another example where I am going to use a model. All right, so in this model, I've got the x's that we talked about on the other page, and I've got all those ones. And I've got x's and all those ones. So let's start eliminating what we can. Go ahead and start crossing stuff off that can be removed from both sides. So x is gone, x is gone. X is gone, x is gone. All right, then I can take all 4 of these and 4 of these. I eliminated everything. I can't eliminate any more 1s or any more x's. So what's left? After I eliminated all that stuff, what's left on the left side? 4. Okay, what's left on the right side? Nothing. The middle means equals. I hope you're feeling just as weird about this as I am. The heck? How does 4 equal nothing? Does 4 equal nothing? Have I been doing math wrong all these years? No, I haven't. Okay, so what equation?
We still have a few extra dinners if you have a bigger family.
Don't you love announcements? I'm glad I paused that because that announcement just got more and more annoying. There's a lot of stuff that they said. Okay. What equation was this model originally representing? Well, there were 2 x's and 8 1s. So I had 2x plus 8. And it was telling me that that equals 2 x's and 4 1's. But clearly, that wasn't true. Clearly, this equation didn't work. That equation wasn't solvable. So what did you notice about the solution? It wasn't true. We talked about this a little bit in the 8th grade. That says true, it's just poor handwriting. So hopefully you can catch that. We talked about these 3 things: one solution, no solution, and infinite solutions. So we'll start with one solution. One solution is when you get an answer like this. X equals, and I'm just gonna say A for some answer, okay? And this works. So the variables did not cancel. If the variables don't cancel, then there's something there at the end, and it works, and your answer is true. Okay, so let's look at the second one. The second option, which is no solution, you are going to get an answer like this. It's going to say A, some answer, equals B, some other answer, and it's going to be not true. A doesn't equal B. So just like ours, 4 equals 0, totally not true. Okay, so what happens on these ones is the variables cancel. And in parentheses, I'm going to say false statement. The variables cancel, and it's a false statement that's left. Okay, the third option is infinite solutions. And it's going to look like this. You're going to have some answer, like 4, equals the same answer, like 4. So yeah, that's true. 4 does equal 4. It's just a really weird thing to tell someone. Yeah, 4 equals 4. So on this one, the variables are going to cancel. They're going to go away. But it's going to be a true statement. All right, so let's try one of those. Let's try a problem like number 11. On problem number 11, I'm going to start by separating my 2 sides here, and I'm going to distribute the 2. So on the left side, nothing changed, 2x minus 5 equals, and on the right side, I've got 2x minus, you might be tempted to say 5. No, you've got to do 2 times 5. So that would be minus 10. Okay, let's get the variables to the same side. You might be thinking something's fishy right off the bat because the variables match. So you might be thinking, oh, I know what's going to happen in the next step. All right, in the next step, I'm going to subtract 2x from both sides. These are gone and these are gone. And this is the part where some of you say, ah, I did math wrong. Ms. Johnson, what happened? Okay, well, let's look at what's left. Negative 5 equals negative 10. Which one is it? Is that true? No, that's not true. So X, not true. I don't know why I did that. I was gonna give it a check if it had been true. Maybe I'll just do like a sad face behind that X mark. This just got weirder. It's gone now. Okay, let's just say no solution because that's clearly no solution. Okay, let's look at another one. Let's look at problem number 12. Separate the 2 sides and distribute. Ah, what do I distribute? There's just a negative there? Fear not. It's a negative 1. Distribute that to everything inside. There's still a 5 outside of that stuff. Negative 1 times 4a is negative 4a. Negative 1 times 8 is negative 8. And I have 5 minus 4a minus 8. That smells like deja vu. Look at all this stuff that's the same. If these are the exact same, think about what that's going to do with the rest of the problem. I'm going to start subtracting stuff and adding stuff, and things are going to cancel from both sides. Let's see what happens. I'm going to combine 5 minus 8 on the left side. 5 minus 8 is negative 3. So I have negative 4a minus 3. And on this side, I can also combine 5 and negative 8. So I have negative 4a minus 3. I can get the a's to the same side, add 4a, And when I do that, I get my variables gone. So -3 equals -3. That's a true statement. Infinite solutions. All right, so I'm starting to see some patterns. I can see that the variables matched and the other stuff didn't. That was a no solution right off the bat. On this one, everything matched perfectly. Infinite solutions. Your job right now is to finish the rest of this page. And actually, I think that this is like your quote unquote homework. This is your work for the day because this is a longer page of notes. So your job right now is to finish this up. You'll take a picture and you'll submit it. You'll also check your work. I don't know, have a really happy long weekend. I miss you already.